conservative, but when you think about it, we're doing visual inspection the same way, in most cases, by the way. I'm not talking about electronics, but we're doing visual inspection the same way we did it for the last 2 million years. And this, by the way, makes it so challenging to compete. When I'm looking who is really Kitov's competitors, it's really the human being who's doing kind of the visual inspection. Because you think about it, you take this object, you look, you turn it, you project on it light and so on. To do this kind of simple task for systems is extremely challenging. And that's why about 90% of the visual inspection today in the world in manufacturing is being done manually, which is kind of unbelievable when you look at other automation that happens in the manufacturing world. Now, unfortunately, although the human being has amazing capability in terms of the eye, brain, the ability to learn and so on, people don't like to do it. And it becomes extremely challenging to find people to do it. And they want more money to do it as well. So that's why, and also when you think about it, it's to try to really do inspection day after day, you miss. We believe people miss about 20% to 30% of the defects when they're doing inspection. On the other side, there's customized solutions, which are really tailored to one specific product. They're doing a relatively great job, but usually very simplistic. Checking if the bottle is filled, checking if the box has all the chocolates, and so on, but not really sophisticated inspection. And we kind of believe that we are sitting in the middle between these two capabilities, and we're doing a very sophisticated inspection of a three-dimensional object. So if you had like a flat panel with a few components and so on, probably Koyang with some other suppliers that are here will do a better job than us. But if you have a more complex kind of products, I think that's where we would like to evaluate what we can do. These are kind of our core capabilities. I will kind of expand a little bit in the next few slides about them, but it's kind of ready to use product. So it's not a project. We bring the product in a day, we start to scan your products. We can integrate very easily to your manufacturing line because we build it as a product and not as a project. And we believe we have superior detection and connectivity to other systems in your factory. When you look in terms of how we do it, I tried in one slide to explain what we are doing. So we have kind of existing libraries of different elements, such as existence, if something exists in the location or not, to analyze surfaces, if you have scratches or defects or oxidation and so on, look on gaps, labels, screws and so on, and we expand this library as we go. Another capability that we introduced lately is our ability to take the CAD model of your part. Could be a very complicated three-dimensional kind of object. You mark on your software, SolidWorks, Creo, whatever, what areas you want to inspect, and that will generate, this is by the way how you mark using the special add-in that we developed on the SolidWorks. You mark kind of the areas that you would like to inspect, and that automatically generates hopefully it will work. Yeah, an inspection plan that really, if we try to do it manually, using a teach pedant or to manually program the robot, would be taking you probably sometimes weeks or months, and that's being generated automatically in this case. I'll come to this later on in the presentation towards the end because there's some interesting event that happened about a week ago relates to that. In terms of connectivity, we kind of present, we can integrate today different type of robots, although we prefer to go with our standard denser robot on our system. Different CAD software, as I explained before, integration to your factory automation and also to your quality systems or MES systems. This video actually shows the full cycle of our inspection. I hope it will work well. Okay, I'll kind of explain what's going on over here. This is the power booster from the automotive world. And we inspect your different things. You select a different inspection plan you want to inspect. You click on the screen and start the inspection process, and then it starts to scan the product. Usually a product like that will take about 20 to 30 seconds inspection time. looking for critical parts, critical elements such as connectors, surface area, labels, and so on. At the end of the process, the user looks on the defect the system found. On the left side, there's a golden reference of what the system expected to look. And on the right side, these are the defects that the system identified and present to the user. So the user can make a judgment if it's a real defect or not, should they change the threshold of the system or not, and so on. So bend pins and so on. Could be broken plastic parts. Some of them are hard to detect using only screen, but I think you can understand what the system can actually present to you. We're looking on defects that human being can detect using the bare eye. We do have an option to increase even beyond that, go down to 40 micron kind of defect level, but this is kind of what we have today. A few more seconds. Here, by the way, we have examples of PDF report that the system generates with the defects that the system saves, and you can then export this information to your factory. When we do it in terms of detection, we actually realize that you need to combine classical machine vision with AI in order to really get a high-end detection level. And so we have some pre-trained deep learning network and also advanced analytics in order to help us identify defects during the scan. To really understand or to prove to you that we have a flexible solution, I kind of use this slide, which I'm showing here samples of 7 products that we scan on our system, completely different. One of them from communication industry, one of them is from, I would say, more power. It's a power converter for solar panels, PCB as well, plastic box, iron dome. If people knows what's that, we actually doing the inspection of the missile head, very complex mechanical and electronic assembly, automotive, and also from aerospace and metal parts from aerospace that are very hard to do the inspection. So this is kind of examples of different defects that we identified, and I will not go into details. If you have more questions, I'll be more than glad to answer them later tonight or tomorrow. Even, for example, here is a soldering position, and we kind of doing inspection for that, or missing parts or parts that are kind of not in the right position. Plastic box defects, in the power booster defects, another open screw, bent pins, and so on. And a very complex jet engine, turbo jet engine defect that, of course, we hope that we fly an airplane, we don't have these kind of defects on the plane that we are flying on. So this is definitely sensitive. We are kind of scattered all over the world with different locations. We sold already more than 100 systems worldwide. We are a young company on relatively early stages, but we already are entered into very large customers and also industries. As I promised you, one more thing. A week ago, there was a very big show in Europe called Vision Show. I think it's the largest vision show in the world, and they had a competition. 70 companies introduced their products, and 5 companies managed to get to the final. Kitov was one of them. And last week, it was announced that Kitov actually won the first prize for our technology of what we call the CAT scan technology, where we actually use the CAD model of the part to create the visual inspection plan. That's it. Any more questions? I'll be more than glad to answer today or tomorrow to people who stay here. Thank you very much.
Thank you.